So thank you, Candide. I'm just going to shut the door. Make sure you can't escape. Oh, it's okay. This is great with this room, right? Because the other one you can come and go from the back and not interfere with the speaker, whereas at least here you feel quite bad if you're leaving, and I get to see who you are, so I can ask you later why. Um, so, so yeah, I'm here to talk about hypervisors and virtual machines. It's going to be a kind of an overview about the attacks that have previously existed, that currently exist, and my current research, where I'm going with it, and what I'd like to do in the future in this regard. I'm currently going under the handle NX. This has been in play for about a year and a half, which means if you look for it, you probably won't find anything so far on it. I've gone under other handles, but for various reasons I've changed. My background is sort of systems programming, system hacking, this type of thing. I had some nasty experiences about, how long, about 14 years ago in the open source community about trying to get anything done in the open source community regarding operating system design, file system designs. So I kind of went and did my own thing for quite a while, and now is kind of it's an attempt to come back into the scene and get some stuff out there. So I'm going to sort of describe a storyline. So it's going to go through backgrounds, very, very quick about virtualization, hypervisors. I'm sure everyone here is pretty much familiar with what they are, where they've come from. If not, then you get a quick 1 slide, 2 slide introduction about that. In preparing for my research and doing the things that I'm doing, I had to try and have a focal point because the whole hypervisor world is exploding at the moment with different vendors. And so I give some reasoning about why I'm currently looking at the vendor I'm looking at, what the available tax base is on offer, what's currently available. This is a few short slides saying what has been created in the past and where we're at now. And I also then want to present sort of, hopefully very quickly, where I'm going in my own research in this field. So quick history lesson, this will be quick. 2 points, where did this all come from? So a lot of people have got the cloud thing understood as the buzzwords, and yeah, but it's been around since the 1960s. I mean, this stuff is all old. I mean, it really amazes me that in the computing industry, we keep going through these cycles of, oh, we've got new stuff, we've got new technology, and you look back at the 60s, 70s, and it's all there, right? I mean, these guys were much smarter than a lot of the guys now, and we just have to go back in the past, and they did a lot better work, in my opinion. So what's also quite cool, I think, about this reference is if you check out the memo and the memorandum of who it's for, members and affiliates of the Intergalactic Computer Network. I think that's cool, right? I mean, this is a sign of the times. This is the 1960s, everything was cool. And yeah, this memorandum really laid out the concepts for cloud computing and sort of host client stuff. Excellent. Get to the 1970s, and what do we have? Formal requirements for virtualizable third generation architectures. I don't know what happened there. They started smoking something different, or you know, it started to enter the serious phase, right? I mean, Manhattan Project was going on, things like this. I thought, okay, somebody's been kicked up the arse and said, guys, this intergalactic stuff, what's going on? So, so virtualization requirements were really defined at this point with equivalence, resource control, efficiency, just fancy terms. If you want to read it, read it. It's kind of an interesting paper. But most of you guys who are using virtualization stuff now will be familiar with this in its sort of modern incantation. Now, I'm not a graphics guy, as you may see from this wonderful thing. Okay, it's not. I didn't draw it, but I used some Microsoft stuff. So, but I tried to put some pictures to make my presentation a little bit more interesting. Timeline of where we've been and where we're going, where we're at. So we can see that VMware was around in 1998, and I mean, this was when it was founded. Now, in 1998, I was still looking at assembler, surfing with CompuServe and AOL and stuff, and yeah, I was quite amazed when I found out that it's been around since 1998. I mean, I was still, as I said, coding assembler things and wasn't really there. So at least you know, when you see the difference between the 60s to the 90s, okay, they had some time to work on the stuff, and now it seems that we're actually getting to grips with Microsoft finally working out this could be interesting and getting involved in the space. So, okay, just to give you an idea of where things stand. So what does this mean? Okay, this is my definitions. What does this whole cloud stuff really mean? So to the old guys who were around in the 1960s doing cool stuff, I think it was like, okay, time-sharing computing, we've seen it all before. They're sitting on a pillow in a kind of a Zen state going, guys, cycles, everything's happened once before, we're there again. The young guys, in my opinion now, if you talk any of the youth, it's like, okay, I've got something on my iPhone, I've got something in my sort of eye sphere. It's accessible everywhere. Why the hell did you guys in the past bother with disks and, you know, transferring things with CDs? I mean, come on. But we don't really care, what or how that works, right? It's just got to work. So, and then there's for the hackers. So hopefully us guys here. Now, there's a lot of resistance usually when you talk about cloud stuff in the hacker space, which I never understand actually, because it's an interesting reverse psychology trick for me. It's I want to sell this stuff to people because I don't want to keep learning new stuff to such a degree, right? I mean, in the past when I was doing some kind of virus playing around with self-adapting code and things, I have platforms and I have chipsets that keep migrating, keep changing. What virtualization allows me to do is, if one vendor, okay, the idea is that if you have one kind of vendor that you can attack, then it makes my life a lot easier. You've still got a lot of technology to play with, the sphere is large, and thank you very much. So as soon as people start going to the cloud, I'm like, okay, great. I don't have to learn 6 different operating systems, 4 different TCP/IP stacks. I've just got one thing I can really go after. So for me, this is a great opportunity. So, I go to the management, I'm saying, guys, go to cloud, go to cloud. It's great. It's going to be brilliant. Look at the cost savings. And in the end, I just want my life to be easier. I mean, I'm quite lazy. I'm getting older now. I'm not 16. I'm not 18. I haven't got like 20 hours in a day to like sit coding. I've got a girlfriend, this type of stuff. So yeah. So please make my life a bit easier, right? Management, go to the cloud. Let me, make my job easier. So this is, again, a nice little graphic I knocked up using wonderful Microsoft stuff, taken directly from Wiki and made into a nice pyramid, okay? The reason I structure it as a pyramid is because I rate it in level of importance. My rating, by the way. So cloud clients, not really interesting for me at the moment. I'll go into why. Software as a service, platform as a service, okay. They're kind of sitting on this guy, infrastructure as a service. And this is the stuff that really interests me from system programming side, because this is where all the juicy stuff lies. Why do I say that? Well, for me, the other levels are sort of hacking at the periphery. Socially based cloud services, as I said, your Facebook, your Twitter accounts, iCloud things, not really that much really interesting. I don't really care if I've got a picture of your dog and you're on a beach somewhere and I want to blackmail you and all this type of stuff. Really not interesting for me. So of course you can exploit this. You can get people's data and things like that. But yeah, not really technically oriented in terms of the system side. I'm sure you're all familiar with Matt Hung hacked recently on Wired. If you're not, please go read it. You should be. But I mean, it was an interesting article about how insecure cloud stuff is in terms from the social perspective. But come on, the guy had his accounts daisy chained, no two-factor authentication, no backups. Now it was a shame the guy lost a load of his data, but he was asking for it, right? And a lot of this stuff can be solved with traditional spear phishing attacks and social engineering. So not really technical. You have, as I said, software as a service, platform as a service. These could be interesting. Software as a service, I think, yeah, leave the web guys. I mean, most of these are accessible over the web, so it's usually open to the now more standards web application techniques. And again, I'm more coming from the system interest side, so from assembler level, what you can do with exploiting system calls. So that's why I sort of end up looking at infrastructure. Plus point, your attack vector in your attack space is much larger. Okay, I mean, when you started, in the old days when you started going against systems, it would be like, okay, maybe I can't get into the main system, so I have to go and find some system that's like a little less secure. Okay, does this exploit work? Do I have to code a 0-day? Okay, I finally got into a system. Okay, now I have to make sure all the logs are cleaned up. What system is this? Then I can try and get to the next system. So I'm doing network scans and so weiter. Now I have a management console and a virtualized infrastructure. So thank you very much. I break it once. Normally I get access to a lot of other juicy stuff without having to go all through the effort of a sustained attack, and this really takes a lot of time, and I just want to speed that up, okay? And as I said, I'm lazy, so that's the stuff that really interests me. So I was thinking, great, this is cool. We've got infrastructure as a service. I just got to attack that. But yeah, now things get more complicated. So about 2-3 years ago, you could say, yeah, look at VMware, look at Zen, good. Now Microsoft seems to get involved, wonderful. Yeah, so you get another vendor in the marketplace. And you also got things like VirtualBox. And when you start to look at just non-bare metal virtual machines, you've just got a whole proliferation of technology. So we end up in the same or we're moving towards the same problem of like OSs, and you've got to learn multiple technologies of which ones to attack. So for my current sort of research, I said, okay, it looks like the whole trend is, I mean, IT guys must just want to make things complicated, okay? I mean, vendors, they annoy me. So I ended up trying to work out, okay, well, which vendor should I attack? Which vendor should really come up as the top dog? So I ended up coming with VMware. That probably won't surprise many of you here. In order to make this decision, I'm just going to run through a couple of constraints I've put on myself. As it's infrastructure as a service, I wanted to look at sort of bare metal primarily. VMware offers bare metal and non-bare metal systems. This means, I'm sure you're all familiar. Are you familiar with this? Bare metal, non-bare metal terms? Yeah, okay, there's definitions here if you don't, wiki it, whatever. Basically, I want to go after that, the bare metal stuff, simply because, yet again, it allows the best breakout to options for full infrastructure compromise. So I wanted to find a vendor that offered both. It's not like the Oracle stuff, which you can only get that does a mapping between your OS and your VM, but like in 2 layers. Okay, if you go after bare metal directly, you just have to go through 1 layer of transformation in the assembler code level. So as I said, and so this matters also because the technology is immature. Okay, what we've got in the virtualization sphere at the moment, hypervisors, is the stuff still not tested. I mean, it's been around since 1998, but VMware has really started thinking seriously about security in maybe the last year, maybe, if you're lucky. Zen's slightly better, but it's still great for us. I mean, the opportunities for exploitation are just waiting for us to sort of get there. And what's amazing for me is we haven't really got any sort of hypervisor hackers out there. I mean, a lot of the stuff that's coming out from the sort of scene at the moment is one guy who's been given a bit of a time to do something on his own, like myself. It's not really supported by the industry. They find a couple of exploits here and there. One hypervisor is, there's a breakout somewhere, but it's not really given the weight I think it deserves. But that's changing, and it is immature, so we still have opportunities to get quick wins and, yeah, make things easy. So who's the biggest market player? This was obviously the biggest constraint. And yeah, I know I mentioned Gartner and stuff here. It's quite embarrassing. I'm sorry. But yeah, these are the 2 groups, independent groups saying, yeah, VMware is the biggest, and it looks like they're going to be the biggest for the foreseeable future, at least for the next year, 2 years, okay? So it makes it for a good environment to go for. So in the end, once I apply the constraints, VMware comes out on top as the vendor that I want to attack. Yeah, it offers bare metal and non-bare metal installations, and what's really nice is the vBlock project. So the vBlock initiative is sort of a collaboration between EMC, VMware, which EMC owns, and Cisco to really come together and provide virtual switches, virtual gateways, the whole kit and caboodle. So for me, this is just music to my ears. I'm like, hey, thank you very much. Now it's like super, everything's getting virtualized, and this is just making my job much easier. So super. So what are we thinking about with VMware pen testing when we want to sort of go against these systems? So previously, as I said, we had to, in the old days of sort of attacking stuff, you could either do good reconnaissance and find a highly protected system and see if you've got some kind of 0-day, or find out some exploit exists in the wild and the patch cycles aren't there, and go for it that way. But it's often a lot of work. And it's on the physical layer. But with the virtualization stuff now, it's gearing up and you've got like this extra layer of dimensionality. So you're still gonna have to penetrate, you're still gonna have to usually pop a box at the beginning, but you only need to get an unprivileged access. That's the difference at the moment. If you can get a guest access on a local machine, then there's a lot of stuff you can then do with that. So forget about trying to get root. That doesn't necessarily have to be the case. So I just want to, again, include some graphics here. This everyone would be familiar with, right? It's just the standard backtrack penetration testing cycle. So I just wanted to illustrate with a slide that once you have the physical layer, now you've got the virtualization layer on top, you have to do more or less the same stuff. But the important thing is that you can do this from guest. Okay, this is quite a critical thing, depending on which attack vector you choose, but predominantly to do cool stuff, you can do it from guest. So you've got a number of perspectives about when you're looking at a system. So you've got 2 scenarios in my opinion. You've got no access to the system, you've got to do your normal reconnaissance stuff to even work out whether it's a virtual machine that exists or not. I'll get to how you do that in a second. And the second part is, okay, you have access to the system. This could be because you're leasing a virtual machine access from a vendor in EC2 platform from Amazon, for example. Perhaps you're an external consultant, you socially engineered a way in to like get a guest access on something. So you've at least then got entry-level access. Okay. Standard reconnaissance methods. I'm not going to spend a long time on this. I only wanted to highlight ports that are relatively interesting if you're going to go after virtualization. 443, 902, 903, 8000 are good places to start. 8000 is the vMotion network in VM, which is the network which allows virtual machines to transfer between. Everyone know about vMotion here? Sorry, before I. Yeah? Yeah, okay. So when you're, maybe not, I'm not sure, so I know it's early morning, so feedback is always a trouble in conferences, right? So you just sort of put a question out there, everyone looks at you, what the hell is he talking about? I'm not answering. And it's like, I need to know, you know? But yeah, so 8,000, so the vMotion stuff is actually the one thing I'm quite interested in, because it's a way of allowing virtual machines to migrate between clusters, and eventually even maybe between networks, depending on how administrators configure this stuff. So a way to sniff on that is 8,000, 903, 902 show management port stuff, and 443 is the management console itself for VMware. Nmap is already up to date with that. Do standard Nmap scans. If the guys haven't protected it, you'll get hits, no problem. Showdown, excellent resource for getting old, outdated stuff. So I'll talk about patch management in a bit later, but with VM, at the moment, the cycles are quite fast, so it's quite hard to keep up to date. But with Showdown, you get a lot of good old systems which haven't been updated, so ESXi3s, for instance, where all of the exploits that I'll show more or less work on them. So that's always good for a test bed if you want to go after some low-hanging stuff and just have a play. And Google hacking, of course. And there's loads of other stuff. This is an exhaustive list. I just want to introduce some key things if you're going to get started in this field about what you should be looking for. So hypervisor identification. Now, this has been in presentations on hypervisors for a long time now. And I think it's really interesting because around about 2006, with Blue Pill, which I'll talk about in a little second, it came about that, you know, people were able to identify if they're in the matrix or not, so they're in a hypervisor. And a lot of people were saying, yeah, this is really bad, and you know, this shouldn't happen. And then everyone sort of went, yeah, but you can do it, and that just stopped. No one really went further with that. No one said, okay, hang on, no, this is really dangerous. You know, if a hacker knows he's in a hypervisor, then he has a whole different objective, a whole different route to play out. So thankfully, no one actually did anything in this field. I mean, to such a point that this guy, Elias, coded up an application for Windows just to test whether you're in a virtual machine or not on virtual PC and VMware, and this still functions perfectly, out of the box, no problem. So on Linux, you've got these, so for a while you had virt.wat, which, you know, required root access, but then what the hell's the use of that? Because I don't want to get root access. If I've got root access, why do I care if I'm in a virtual machine or not? Blah, blah, blah. I mean, for me, it's manipulating the guest, right? So then IMVirt came out. This is a nice tool. It basically pulls on instruction sets of the PC, of the virtual machine, how the translation happens, and does pretty good, reliable results on telling you if you're in a VM or not. There are other tricks here, which you can code in assembler. Really easy to do. Grab the code off the net, knock it up, compile it. It's, yeah, no problem to do. Max X, I have no clue. I've not tested. My research doesn't cover that. I disdain Macs. I'm a PC. I state that on my laptop. And I'm not going to bother testing. Now it's a Unix flavor underneath. I'm sorry, maybe I offended a lot of people by that Mac statement, but you can talk to me afterwards and we can discuss this further. But and not to say anything about control or anything, right? But anyway, and no free thought. But anyway, so I don't know if this works, but these are assembler stuff, and this should be fine. And what's really nice is VMware backdoor. Does anyone know about VMware backdoor? How it works? This would be a really good opportunity for people to give me feedback now, right? So it's just okay. So the VMware backdoor is a backdoor channel that VMware uses for its VMware tools, predominantly, and for drivers and power virtualized drivers to communicate on. This is completely open, okay? Completely. And with this, you can code up an assembler program, send commands such as 01H to CX, OAH, and get a lot of useful, tasty VM information about the host. Hard disk stuff, everything. Some of the stuff is documented, some of it not, but there's plenty of guys out there who've found out, you know, oh yeah, undocumented feature, just pump this into address, you'll get this information. The great thing is it's not locked down at all. You can do, the VM administrators can do some kind of tightening, but the main point is it's open, and there's no indication from VM that they're going to close that. So if all of these methods were to fail tomorrow, we still have this, which the vendor is supporting, and says, yeah, it's okay, it's open. So to find information about your host, to find out how much hard disk space that's got, to find out what version it's using, anything, as long as you've got guest access, it's all open for you. So beautiful. Past, present, state of the art. So I just want to quickly run through some of the stuff that's out there that you may or may not be familiar with. I think it's useful to know where the field has been and where it's going. The Blue Pill, everyone heard of the Blue Pill? So yeah, nice bit of kit, root kit. Yeah, invented by, she's been a bit of a rock star in the virtual world, especially from the security side. So Joanna from Invisible Things Labs. So she created this, yeah, the blue pill rootkit, which was supposed to avoid detection from everything. This was presented at Black Hat a few years back. Yeah, it's there's some controversy about it, about whether it can be detected or not. I've implemented myself elements of it as a proof of concept, and nothing was detected on Windows 7 machine when I implemented this type of stuff. So I don't know. Better people than me may argue the point, but I think this is really cool. And this is really cool also for later in my current research with what I'm doing, or what I hope to do with virtual machines. VM chat. This is just to illustrate. Illustrate a nice client-to-client breakout. So basically, the guys Skudis and Liston. Unfortunately, their material is guarded from the Department of Homeland Security in the US. I've been in contact with them, so I can't demo it here. But some of their techniques apparently still work. Because it wasn't publicized, of course, then VMware probably hasn't patched it, so it may still exist now. I still have to work out exactly how they managed to get the COM channel on and out of bounds through the memory exploitation, so I'm not sure. I'm trying to tease some information about that, but at the moment it's proving tricky. But just to show what can be done, I mean, okay, 2006, so we're going back 6 years. That's some time ago in the IT world, okay? But just that was the beginning, more or less, of some cool stuff coming out. 2009, again, Black Hat. Costa presented the exploitation that manipulated 3D support under ESXi by basically writing data to an out-of-bounds glyph and then being able to just jump from there from the guest to the host. So this was all really cool. And I mean, what he presented, he did a good job with the presentation. It's well worth checking out. But of course, he's part of Immunity, and then they packaged that with Canvas, and yeah, I don't know who can afford Canvas here, but I certainly can't. So this was a bit of a pain, so I really wanted to get involved in how this really works. So there was a really great guy, Piotr, who basically after that, and realizing that was now locked in by a vendor, decided to write his own version. I have the source code. He's given me permission to, if anyone wants to look at it, he's a really open guy, you can have a look at it, of how it works. And he demonstrated using the same vulnerability, an XP3 host to XP3 virtualized VMware breakout, where as a guest, on a guest account, I run an application and I can then load anything from the host. So in the example he gives, you run calc.exe, but of course you can just exploit the entire system from the guest with no effort at all. I mean, it's just brilliant. So that was cool, but again, that was 2007, so we're coming quickly up to speed now. Metasploit. Everyone familiar with the Vasto framework here? Not? Yes? No? Okay, so just in case you're not, but you use Metasploit, as I'm sure most of you do, there is now a Vasto module which you can download. I think it may be bundled with the next version or the latest version of Metasploit. Last time I checked, it wasn't. This is developed by Claudio, a really great guy. Basically took a load of stuff out there in the wild and weaponized it in Metasploit, made it really easy for all us guys to not have to worry about that and just go, oh yeah, our host, give me this VM. So, I mean, this was just brilliant. This was basically taking all the hard work away from us. So what you have in there is modules such as VMware Guest Stealer, VMware Session Writer. I haven't tried the Zen or Eucalyptus modules, but the VM ones work for versions 3. The issue we're having is that VMware does updates. So for version 5, the VMware Guest Stealer option doesn't work. But him and I are hopefully going to work on a version 0.5 and maybe look at making improvements on that. At least I'm in contact, and we hope to get together with that. So that's useful because if you get, maybe you get guest access to a virtual machine, but you're not able to install the Metasploit framework because it's quite big and blah, blah, blah. Just get the Ruby module and just run it from there. That'll just work straight out of the box as well, and then you have everything you need to break out from your guest system. So the nice one, as I said, is the VMware Guest Stealer. He has other ones like brute forcing, the management console and things. The Guest Stealer is particularly cool because it means if you've got a guest access on a local system and I want to get every virtual machine that's also on that host, I just run VM Guest Stealer and download a copy. So I have all those machines. You know, if you get the security stuff, it's just there for you to get. And just using a directory traversal attack. I mean, great. I mean, what are VMware thinking? I mean, directory traversal attack. I mean, literally, the code is like, dot slash, thank you very much, from guest, right? And you're just thinking, cool. I like this type of this approach to security. Thank you, vendor. So, right. Unfortunately, I tried to do this on ESXi 5, and they have patched it. So so just as a warning to all you hackers out there, ESXi 5 has been greatly improved from the security perspective. Okay, but then if they didn't improve anything, it would all be way too easy. This is some latest stuff coming from Sans. I'm not such a Sans fan, but just so so somebody doesn't come back and say, "Hey, haven't you heard of this?" Because it got some news coverage recently from Mark Baggett. He basically was able to say, "Okay, if you get a VMware image file, you can pass the hash really easily because essentially everything is like this, clear text." So you've not got any kind of on-site encryption of the VM images. You just say, well, thank you very much. Create a memory image through standard tools as we're all familiar with, volatility, and there you go. Let's just brute force this. So, okay, so I'm using VMware Guest Stealer out of the box to steal VMs. Should I run into credential issues, which I then load up on my local machine? Well, then I just pass the hash and thank you very much. All off the customer machine, right? So I'm not even having to worry about time constraints. I can just sit there, throw hashes to the cloud, your favorite cloud provider for cracking hashes, and go back, take a coffee, and come back 2 days later, and there's your network. Then I have access to whatever machines you have on your virtualization segment, okay? Kind of worrying, maybe. At least not for me, but maybe for the industry. This is also one recent release of some software that just came out, which is really cool because I tried to do this, as I said, about 15 years ago in assembler for viruses and failed. I tried to create viruses that were self-adaptive for Mac OS X PPC and RISC x86 architecture. Now everything's sort of going at x86, at least on the client side. This is really cool. So here we see there's got this jar file, it's adaptive, it works out whether you've got a Mac OS X computer or Windows. And the cool thing about this is it's now looking for VM as well. So because the VM image is stored in clear text, you can essentially write your virus package, whatever, into the appropriate place in the image file. And then when the person mounts that image in their VM, it's then coming with the virus already instantiated. And of course, who's checking text files, right? I mean, you haven't got text monitors monitoring your VM image files. So pretty cool, huh? I mean, I just showed this because of some VM entry points. Maybe some people are interested. By the way, the slides should be available, and on all of the slides where I've got references to work, there are the corresponding web links, okay? So you don't have to hunt around for this research or Google the names. Literally, just go to my presentation, click, you're directly presented with the paper, okay? And this one's really cool. This stuff is awesome. So this is the VMDK stuff, and I wish I'd done it. These guys from ERNW, we're taking the idea even further with the VMDK, so your virtual machine descriptor files. And there are cloud vendors out there now who allow you to upload your virtual machines to their environments and utilize their cloud services. Brilliant. Except for the fact that because of the clear text nature of the configuration files, you can start doing some fuzzing. And with the fuzzing, you can start exploring the unified file system that those virtual machines are hosted on. This in turn means you essentially manually update a VM configuration file with some text. You can then mount other disks from guest of the host in the virtualized cloud environment. Which is, I mean, bear in mind, these cloud vendors are probably multi-tenant, right? So they've got other customers' data there with other virtual machines, and you just add 3 lines into a virtualization configuration file, upload your VM, and oh, look, now I have access to those systems. So I highly recommend you check out their presentation slides. It's pretty recent stuff, and it works for ESXi 5. And this is all from guest, right? So no additional access levels at all needed. So thank you very much. Really wicked stuff. So appraisal, cloud is upon us. Thank you, great for me. People are going for it because business only cares about money and it's cheap. So brilliant, forget about security, right? The backdoor for getting reconnaissance information isn't secure at all. And there is a chance that it's not going to be secure in the near future. And also, not many people know about it. So they don't know how to write an assembler program that can then set this up as an instruction set to get the required output. I mean, a lot of pretty good VM engineers also aren't aware of how this VM tool communication is really working. Okay, so this is a really nice sort of information reconnaissance channel, which I recommend you all sort of just have a look at and play with in your environments and become aware of it. If you're really at clients and you say, that's something you need to work out about locking down. You can't lock it down completely, as I said, but you can do a kind of okay job at locking some things down. This stuff is new, this VMDK exploitation stuff, and is really quite dangerous. So I don't know how these cloud vendors really plan to solve that. And as long as VMware is giving clear texts, VMDK files, and then non-sanitized inputs. That breach is gonna last a long time. I haven't covered it really in much detail here, but the vSphere stuff, SOAP calls are vulnerable. This has also been demonstrated. The vSphere stuff is really a nice thing, which if you can exploit through a man-in-the-middle attack on the SOAP calls, through HTTPS requests, you have access to the entire infrastructure in one nice console. So, to give you an idea, I just download the client to my PC, I get the IP address, I dial up that, I've managed to get the password through a man-in-the-middle attack, whatever. Then I have full access to the whole infrastructure. Thank you very much. Admin, boom, yes, thank you. I can do whatever I want. Delete VMs, create VMs, destroy your entire infrastructure in a few clicks. Fantastic. Great. So this is also brilliant. Again, this is one of the advantages of the virtualization world, right? We don't have to worry about a physical server. Oh my God, Well, to destroy that physical server, I might actually have to break into your data center. Well, we all know that firms care more about their data centers than their software stuff, right? So you try and get into a data center, green or anything here, that's pretty hard, right? You've got fingerprints, you've got doors, security, God knows what. You can social engineer, of course, but it sometimes works. But most of the time, that's pretty tough stuff. Whereas now, it's like, okay, it's just a bit of software still. It's a flat file, non-encrypted configuration file, which is holding all your cool data. Okay, the world gets so much nicer. I don't have to learn to go with guns and things. So, yeah, so again, the VMware backdoor is always available at the moment, and the vMotion network transmits the image also in clear text. So VMware come back and say, okay, we acknowledge that this could be problematic, but your network guys should be designing it so the vMotion stuff goes on a secure network out of bounds from the other network. But who really is doing this? Believe me, I've seen nobody do this except maybe some VMware vendors. Some VMware engineers directly from VMware. So which means that the vMotion stuff, they just click, click, click. It's working, cool. But they can automate this. So you can say, okay, so I've got a VMware running in this cluster, and if the threshold gets exceeded, then this VMware will automatically transmit to another cluster. That transmission is happening in clear text. All I need to do is sniff the network. So I just sniff the network. I say, okay, this is the start tag, this is the end tag. Thank you very much. Reconstruct it. I have your VM. Perfect. I'm a guest. I'm all in guest. No privileged access. So, and it's all in clear text. It's just beautiful. So, yeah. So I should try and be a bit optimistic, I suppose. I don't know why, but I suppose I should, just to be balanced, right? So VMware are doing silent patching. I don't know. There's people who say it's a good thing, people who say it's a bad thing. They are getting their stuff together. As I said, the 5 release is much better than 3. And okay, so they're doing some stuff. Great. The cloud vendors should be sort of patching their systems and keeping up to date. We know this doesn't happen, so that was kind of an attempt to be optimistic. If they did what they said they should do, it should be a good thing. So security is getting focus. VMware offers the same sort of functionality as the hardware world. We can do VMware profiling, which means creating golden images, which are supposedly secure, but then that's only securing the OS, of course. That's not securing the hypervisor itself. So that's why I was trying to focus. The hypervisor is vulnerable here, right? And if you can compromise the hypervisor, forget about all your other security, okay? And VMware Update. This is a neat little utility from VMware which says, okay, we'll help you update all your platform with this automatic updating thing, much along the lines of Windows Update. I have an interesting point about that in a second. Pessimism, so great, much more interesting. Okay, so going back to the VM backdoor, really important and really, I can't stress that enough, that it's not locked down. You really should get involved with working out how to exploit that. The shared resources stuff, yeah, you're never going to get that proper segregation where you can really say, okay, we physically separate these boxes in a virtualized landscape, which means you're never going to get the same level of security, in my opinion. Okay, asset segregation, as I said, that just goes on about the same thing. So it's a bit of a catastrophe when firms are going in that direction and they're not securing at that level. And you can never really move a box physically. It's just all this metadata kind of flowing around. This guy, Derek Soda, he's pretty cool. Recently released 3 CVEs. They haven't been sort of weaponized yet. I've been in contact with him, and I may have a look at this simply because we see in March, he found a ROM overwrite privilege escalation vulnerability. Following in May, he finds unprivileged code execution from the guest machine, and then once again in May, uninitialized memory potential VM breakouts. So 3 excellent CVEs which have not been patched yet and have been sitting there since May and March of this year. Feel free to look at them, use them, and make exploits. Patch cycling, brilliant. Okay, so this was just straight off VMware's vendor's site, right? Does VMware have a scheduled patch cycle? When do release patch cycles occur? Blah, blah, blah. There is no patch release cycle, as Microsoft has for its operating systems in VMware. You can check continuously in Update Manager. Okay, fantastic. So we've got our, you've got to have a guy really checking this and then going agree and patch. As we know with the Windows patching world, this doesn't necessarily happen. And it's also, well, okay, if I have to bring my ESXi offline, that means my infrastructure comes offline for some reason. So the risk factor there is like, you're gonna get a lot of managers going, we don't do that. Okay, so this is kind of dangerous stuff. And just to give you an idea, up to August this year, this is the kind of number of security advices that were issued per month by VMware. So if you've got one guy trying to monitor these VMware patch things, you're gonna have a full-time guy doing it. And with the added problem that, that you might have to take the ESXi offline potentially, I can't see this kind of working for the future. I just want to mention, this is just a plug slide really. If you're interested in this stuff and how to do it correctly, I really recommend you check out the Invisible Things Labs. What Joanna's doing there with Cubios, or however you pronounce this, she's really looking at segmented security from not just from a sandboxing level, but from really a machine and virtualization level. So she's generally working with Zen, which I know also has its problems. But her and her team are pretty hot cracks on this stuff, and they've got their own kernel together. You can download this now. It's just gone to beta. You can actually just download this release and start playing with that. As hackers and geeks, I really recommend that. Okay. The problem is, okay, this is a bit of a blah blah, but the problem is, she says iOS, what they're doing sandboxing is kind of cool, but you have fat APIs which have massive problems, and I'm sure if any of you play with iOS, you know about how you can just break out of that stuff. And so what she's saying with her stuff is that it's actually the user responsibility for making all the security decisions. So who wants to go to management and tell them that, right? That's never going to happen. But at least for us, if we've got security concerns, we should get involved in that. It's going to work on Linux, so yeah, hey, fan for us. And it's really an excellent tool to start playing with about how you segregate your data into security segments on your machine. So I highly recommend getting involved in that if you're concerned about virtualization. So I just want to quickly, now I've got like 10 minutes left, so I just want to quickly talk about what I'm kind of doing. I haven't got demos available here simply because I need an infrastructure behind, and I tried running an infrastructure on my laptop with EXI virtualized in Workstation, so dual layer virtualization and blah, 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 and just didn't come off. So then I thought, well, okay, then I have VPN connection from here to my home to do that, and then I thought, well, given the people who are here, this is maybe not such a good idea. So yeah, I'm afraid you don't get the privilege of seeing what I'm working on directly. But what I would like to propose, and if anyone has any sort of inputs to this, please come to me about this, is a kind of a new form of malware. And what I mean by this is, it's kind of parasitic in the nature that it binds to the host and stays with the host. So what you have in a virtualized environment is data in transit. So you have data with this vMotion transitioning between clusters. I mean, I even heard of companies, I couldn't believe this, they have systems getting deployed in a segmented development environment on the virtualization platform. Once that's approved and they think that's okay and it's static and locked down, they migrate that to quality and then to production. So this means if I can infiltrate the system of development, the data will get transmitted to the productive network with my malware, because the idea of the malware, this parasitic malware, is it infects the host and stays then with the host. The idea is not to then go out. It's kind of like the old days of the permanent stay resident stuff. It's kind of in that kind of way. As I said, this is a kind of proof of concept at the moment, and it's still sort of a work in progress. It's at the moment just consisting of a load of scripts. I hope to sort of put that more together in an actual application. And I'm also looking to integrate the blue pill kind of stuff. So you've got a rootkit sort of functionality there. So the actual application is hidden then from the whole system, so it can never really be detected. So I kind of sort of got on a mode of operation in this, again, just to add some graphics and make you guys not fall asleep. Maybe sit up. I mean, I know it was heavy drinking last night. So the idea would be that you sort of identify the environment, you exploit the system. Okay, that's kind of given. Identify the environment, perform a kind of reconnaissance. So this kind of rootkitted parasitic malware will sit on the system and start like hitting the VMware backdoor. It will start sniffing network passively, looking for any tags concerning other vMotions things. If it finds it, pull it out, send it back to its host in kind of a command control center kind of style. I'm not talking about, this is a proof of concept, right? So I haven't discussed how you'd hide this kind of network traffic from the VM and break it. So it's still in the early stages, right? The test constraints, trigger migration, and reconnaissance. So the test constraints, trigger migration was an additional module I was considering, and this. Sorry if I. Sorry about the slide. So this means that it tries to manipulate the vMotion stuff. So the vMotion stuff allows you to actually script and say that after, like, let's say, when a CPU on this cluster reaches 80%, trigger this machine to move over to here. So it's automated, let's say, resource allocation. Well, this is really cool because if people have automated that for me, then that means my parasitic malware gets migrated to another cluster and can sniff on other virtual machines that might be on that cluster. And yeah, maybe they can then go around the network. And so all I need to do is give the CPU a lot to do, right? So we all know how easy that is, right? Just dump some stuff to dev null, come on, generate me a random number or something. You know, watch the CPU escalation go straight up. It happens at night, no one's really monitoring this. VM transitions, everyone's saying, well, fine and dandy. My malware is a rootkit, so no one really knows it's there. Maybe they're not really bothered about really digging into logs to see why that is. It's happened automatically. Fantastic. I'm on a new cluster. I have a whole load of new stuff that I can play with. Fantastic. So this is what I'm trying to build at the moment and get out there and sort of, and if people have inputs to this and whether they think it's a crazy idea, whether they think whatever, please, I'm really open to this. This is the first time it's kind of been presented, so to people other than myself. It could be a crazy idea, right? I mean, you guys could come to me and say, John, you're just nuts. What the hell is this? It's never going to work. Please, I'm open to that. So this is my environment. What I have at home is I'm using as my test bed, just for some background. My objectives. So I want to demonstrate the potential new threat that may be coming up. As I said, I'm not familiar with so many hypervisor hackers out there. So the work usually revolves around just taking some existing exploit or whatever that some cool system crack has found in assembler and gone, okay, let's weaponize that, let's see if we can put it into space. They haven't started really focusing on the virtualization platform as a whole to manipulate. So that's what I'm trying to demonstrate with this POC. As I said, one of the main objectives from this is to simulate high loads on the guest OS to trigger the vMotion stuff. So just going to, these should have perhaps been together. What we could then do is let's say I managed to get this in place and I'm just a malicious user who doesn't really care about getting your information. I just want to bring your network infrastructure down. Well, why don't I just cause a DOS attack? And you're like, well, how do you mean by that? Well, if I can trigger your vMotion to move my VM into a different cluster, I can continuously do that. And to the point where your VM, your ESXi server, will just overload, and you can't do anything because you've got a VM constantly in vMotion going chung 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 chung. So if I have that and deployed on multiple systems, your basic ESXi infrastructure has a problem, and when it has a problem, you have to have a restart, right? And what does the restart mean? Then it means, yeah, your whole infrastructure is down, depending on what you've got hosted there. So I think that's kind of cool. There's also apparently a DB overload limit, which I'm not sure about and I haven't tested, but that's also something I want to explore with the POC as well. If it's got more than 31,000 files, you can just cause the pink screen of death, which as it is in VMware. But that has to be tested. That's again one of the objectives of my POC. Also explore clustered hosts in the virtualized infrastructure. So this would also be network sniffing, seeing what else is going on, password sniffing on the normal network, this type of stuff. And yeah, as I said, so that kind of goes hand in hand with performing reconnaissance analysis. So it is a work in progress. Watch this space. Providing people don't come back to me and flame me and say, man, it's a stupid idea in the next, after this conference and perhaps in the next couple of months, I will be preparing a white paper on it so that everyone can kind of understand a bit more and hopefully have some more access to demos and things that I'll make publicly available. I'm kind of a fan of Woz. He's a pretty amazing engineer, even though I'm not a fan of Apple. Yeah, so I just like this to state this, you know, he's really worried about everything going to the cloud. I think it's going to be horrendous. I think there are going to be a lot of horrible problems. And I say, guys, hackers, let's make it so. So, final words. Well, hackers out there, as I said, this reverse psychology mechanism I think is really valuable. We want people moving to the cloud. It's a really interesting platform to play with, to explore, to break. Yeah, go out there and have fun. If you're into the system stuff and not the web stuff, I know everything's going web now. It's kind of like, for me, it's really great because I go back to kind of where my roots were and I don't have to worry about SQL injections and all that stuff anymore, which it's cool, but it's not really my main focus. The young guys, yeah, they just keep using the cloud, and that's great because they're the guys that also put the pressure on business for us, and basically, you know, everyone wanting their iPhones and stuff. Well, thank you very much. Keeps me going in this area of research. Without some people just going cloud, forget it. It's a really bad idea. And the old guys, again, they're sitting on their stools, smoking their pipes, going, well, we've seen it all before. And, you know, yeah, you're going to start using self-adapted code that we were coding when we were like, 20, and you guys have forgotten how to do. So, slight warning is that, yeah, that the new piece of malware might be lurking. I hope that I can produce this. Thanks for listening. And just as a final thing, recently I was in contact with the guys at VuPen, and they just released a new Citrix Zen guest to host breakout. Check it out. It's there. It's in the wild, and should be worrying for people like Amazon and EC2. So, yep, thanks for listening. I'm afraid we're coming up to the end now. It was pretty tight with the time. Questions, come to me afterwards. I'm here all day. I don't know if I know we've got a coffee break, so maybe you can just come afterwards. I don't know if you want to field questions now. We've got time. 2 minutes. Anybody want a couple of questions in? Wow, okay, everyone slept. Everyone's really done. Okay. So I hope I kept you awake. Yeah, I really do. This is the first time I've sort of presented this stuff. Feel free to rip it apart. I'm really open to criticism. And as I said, it's kind of like a while since I did any presentation along the security lines, and I'm really happy to have input. So please come to me if you think of anything and feedback. We'd be really appreciative. Thank you all for listening. Cheers.